Okay, in this video we're going to talk about the first derivative test and sign diagrams. Okay, so to find relative extrema, it's not enough to know that the derivative is 0 at the point of interest. We also need to know what the function is doing before and after a. All right, let me draw a diagram to illustrate this. So this function has two places where the derivative is 0. One is here and one is here. So even though the derivative is 0 at both these places, both places are not relative extrema. Only this one is a relative min. The second one is neither a relative min or a relative max. So it's not enough to know the derivative is 0. We also need to know what the function is doing before and after. In the case of relative min, we need to know that the function is decreasing before, and increasing after. If it's increasing before and increasing after, then it's not going to be a relative min or a relative max. All right, so now we're ready for the first derivative test. So this has three parts. If the derivative, f of x, goes from negative to positive across x equals a, then f of a is a relative, also called local minimum. If the derivative goes from positive to negative, across x equals a, then f of a is a relative maximum. And if the derivative does not change sign, across x equals a, but the derivative is 0 at a, then x equals a, then a f of a is a horizontal point of inflection, also called HPI. Okay, and we can use a sign diagram. To bookkeep these signs of the derivative. Okay, let's do an example where we use the first derivative test. We'll call this example 1. So find the relative extrema of f of x equals x to the fourth minus 8x squared plus 4 using the first derivative test. All right, so first thing we're going to do is take the derivative. So the derivative of this function is 4x cubed minus 16x. We'll take the derivative and set it equal to 0. Let's factor out the 4x. We'll get x squared minus 4. which gives us x minus 2, x plus 2, if we continue to factor, which gives us 3 zeros. X equals 0, x equals 2, and x equals negative 2. Those are our 3 zeros, our 3 places where the derivative is 0. Okay, so the derivative is 0 at negative 2, 0, and 2. What we want to do is figure out what is the derivative doing before and after each of these zeros. Okay, so we're going to pick a value before negative 2. Let's look at negative 3. And we're going to put that number into our derivative function. And if we do that, we'll get out negative 60. So before negative 2, the derivative is negative. It's negative because at negative 3, it's negative, and it's not going to change sign. It can't change sign without passing through 0. So it's got to be negative for every value before negative 2. Then if we put in negative 1, we'll get 4 times negative 1 cubed minus 16 times negative 1, which is 12, positive 12. So now it's positive. It's positive between negative 2 and 0. And then we're going to put in 1. That's between 0 and 2. We'll get 4 times 1 cubed minus 16 times 1. That's negative 12. So now it's negative in this region. And then we'll put in 3. 4 times 3 cubed minus 16 times 3 is positive 60. So now it's positive again. All right, so now we can identify the relative min and relative max. We can see that negative 2, f of negative 2, is a relative minimum point because the slope before negative 2 is negative and the slope after negative 2 is positive. So we're at a situation like this. 2 f of 2 is also a relative min. For the same reason. It's negative before and positive after. And then 0 f of 0 is a relative maximum point because it's positive before, positive slope before, and negative slope after. So we're in this situation.